Good evening everyone. I am Harshan Vikramarchi from University of Peradeniya, Faculty of Engineering, Department of Mechanical Engineering. Today I am presenting my Mechanical Engineering individual research project for the midterm project evaluation. The study focuses on the offshore wind wave combined resource assessment in the southern coastal region of Sri Lanka. This project is supervised by Ms. Lekha Bakmeedeniya, Professor Prasanna, Gunawardene, and Dr. Ravindu Lokuliyana. Sri Lanka is transitioning towards offshore wind energy as a key component of its renewable energy strategy. Offshore wind has several advantages over onshore wind, including stronger and more consistent wind speed, reduced land use conflicts, and the potential for large-scale energy generation. As per the World Bank report, has identified 3 key areas in Sri Lanka with significant offshore wind. Northern region, Vamanna to Palk Bay, Western region, Puttalam to Colombo, and Southeastern region, Matra to Hambantota. The World Bank study estimates that Sri Lanka has a floating offshore wind potential of 12 GW, particularly in the southern region. This highlights the need to explore hybrid energy solutions by integrating offshore wind with other renewable sources such as wave energy. By analyzing this data, we can see that the southern coastal region, where Matra to Hambantota has the highest wave energy potential. This makes its ideal location for a combined wind wave resource assessment. Since this research focuses on hybrid renewable energy systems, the southern coast stands out due to its strong offshore wind potential as confirmed by the World Bank report and its high wave energy levels. Studying this region will help determine the feasibility of maximizing energy output by combining both resources. This is my process so far. I started with the comprehensive literature review focusing on offshore wind wave energy studies, including the World Bank report on Sri Lanka's offshore wind potential. Next, I developed the methodology proposal, and currently I am in the data acquisition phase, gathering wave energy datasets to complement the wind analysis. The next step will be focused on mathematical modeling and simulation, integrating wind and the wave resource assessment to determine the feasibility of hybrid energy system for the selected region. For this research, I have referred to a wide range of literature related to offshore wind and wave energy. However, in this slide, I highlight the most important paper that served as the anchor study for my project. This paper was authored by my supervisors in collaboration with the Mechanical Engineering Department of the University of Peradeniya. It provides a comprehensive wave energy resources assessment for Sri Lanka, forming the foundation for my research. While this study focused on wave energy, my project extends its scope by performing a wind energy analysis for a selected region and integrating both wind and wave data for combined resource assessment. The methodology used in this research follows IEC technical specifications, a globally recognized framework for wave energy assessment as shown in figure 1 on the slide. This methodology consists of 6 key stages. First step is define assessment stage, then data collection and analysis, the wave model selection, then model tuning, calibration and validation. Fifth one is analysis and resource mapping. Finally, incast and standard reporting. This paper plays a crucial role in shaping my methodology and ensuring that my research aligns with international standard for offshore energy resource assessments. And this paper, feasibility study of offshore wind energy on the coast of Sri Lanka, is particularly important because it's one of the first offshore wind resource assessment conducted for Sri Lanka. While I am not following the exact method used in this study, it provides valuable insight into offshore wind feasibility, site selection criteria, and wind resource assessment techniques. The methodology in this paper utilizes the ERA-5 wind data and general bathymetric charts of the ocean, with wind atlas analysis and application program software for wind resource modeling and turbine siting. These techniques provide a strong foundation for my research. This slide presents the proposed methodology for my research, which consists of 2 main components. The first component is wave energy assessment. The wave energy assessment has already been conducted as seen in the anchor paper I previously discussed. My task is to review this study and adapt it into the selected area, the southern coastal region of Sri Lanka, to ensure the methodology aligns with the specific characteristics of my research area. The second one is the offshore wind energy assessment. This is the primary focus on my study. Since no offshore wind resource assessment has been conducted for Sri Lanka in detail, my work involves data acquisition, mathematical modeling, and model validation to access wind energy potential. This flowchart slide outlines the research process. The study begins with the literature review, which provides the foundation for both wave and wind energy assessments. Then the wave energy, I refer to the anchor paper, modify its methodology for my selected area and analyze the results. Then the wind energy, I focus on data acquisition, modeling and validation, ensuring that the results are accurate and reliable. Finally, I will combine the wind and wave energy data to perform a comprehensive analysis leading to the final report presentation. Currently, I am focusing on offshore wind energy assessment, and in the next phase, I will integrate both datasets for complete wind wave combined resource assessment. This slide represents the data acquisition process, which is critical step in building an accurate wind energy model. I have gathered the necessary dataset from the well-established sources, ensuring reliability and accuracy in my analysis. The primary data sources used are ERA-5 reanalysis data, a globally recognized dataset from the European Centre for Medium Range Weather Forecast. It provides high resolution wind speed, direction, and atmospheric parameters at different altitudes, which are essential for offshore wind modeling. And then next one is general bathymetric chart of the oceans, a detailed bathymetry dataset that maps ocean depths and seabed characteristics. This is crucial for evaluating the turbine foundation feasibility and identifying suitable location for offshore wind installation. These datasets provide the baseline input for the numerical modeling, allowing me to simulate offshore wind potential and validate the results. The next step involves using the data to construct the refined and mathematical models for wild wind energy assessment in the southern coastal region of Sri Lanka. This slide presents the mathematical modeling software option that can be used for the offshore wind energy assessment. Since modeling plays a crucial role in coastal wind energy potential, I am currently researching which software would be the most suitable for model development in my study. The key software options being considered include REV, Renewable Energy Potential Model, an open source tool developed by the National Renewable Energy Laboratory. It is highly promising due to its flexibility and accessibility for wind energy resource assessment. I am currently exploring whether REV can generate results comparable to industry standard software. This slide outlines my future plans for completing the research project. Now that I have acquired the necessary wind and wave energy data that I am currently evaluating mathematical modeling software, the next step involves processing towards model development and analysis. The key steps include obtain the result of wind energy analysis, review the swan model, develop for wave energy analysis, conduct the wave energy resource assessment, combine the results of two assessments, and finally results and report. And this slide is the key reference used in my research. This includes studies on wave energy assessment, offshore wind feasibility, and mathematical modeling methodologies. Thank you everyone for listening.